What's up guys, you're on GCSE iGCSE revision for cyclic quadrilaterals. This is the medium level, so we recap some basics and go to problems that are going to be vary from basic level up to advanced. So not really advanced, but you'll see some maybe troubleshoots that you might experience during solutions. All right, so I want to give a big shout out to new subscribers. Thank you guys. Join and enjoy. Probably you might use that information. It will be useful for you as well. Okay, so let's get started. First, we're gonna recap what cyclic quadrilaterals are, and I give just definition. So it's a convex quadrilateral, four sides, four vertices. That's inscribed into the circle. So all vertices should be on the circle curve. Okay, so that's the main definition for cyclic. And you remember, as for any polygon, the sum of all interior angles, so the sum of all interior angles, interior, which is actually inside there, so like this, is going to be featured to the rule n minus 2 times 180 degrees. That's for n polygon with n sides. However, for 4 sides, you understand that the sum will definitely should give you 360 degrees. But on top, so that's fair for any quadrilateral. It doesn't matter is it cyclic one or just it's not inscribed in the circle. However, for cyclic quadrilaterals, on top of that, there is a specific rule that tells you if you take two opposite angles like D and B, you'll have the sum of them to be 180. So D angle plus B is going to be 180. And the same for two other opposite angles. I'm not going to prove that, but I can just give you a hint why it's so. So if you want to see the full proof why, so just have a look at not revision but cyclic quadrilateral explanations. So however, I can give you a hint why is it so. So you understand that if we take, for example, angle B, it's inscribed angle. So it's on the points A and B, let's say. And if you take the center of the circle and arrange the angle which is A or B, so in this case it's going to be a central angle. So that's why angle B is twice less than the central angle. So that's why it means that the measure of the angle B is going to be half of the measure of the central angle O. So if you go around, that means it's a measure of that arc, which is AB arc minor. So minor. Okay. So this is minor arc. But you also have the major arc. So in total, if we add basically angle D and B, you'll get half of the measure of the full circle, which is actually 2 pi, or in radians, but in degrees is going to be 360. However, it's half, so you'll get 180. So that's why you'll have another useful rule, which is actually applicable when solving problems dedicated to cyclic quadrilaterals. All right, so we also have an external or exterior angle. So angle D is, in this case it's alpha. So this exterior angle, and it will be equal also to the opposite interior angle. So in this case it's interior and it's also alpha. Why? That's pretty easy. I can prove just right here. So here's the angle 180 minus alpha, right? Because in total it opens angle. So it's open angle. So that's why around this point. Okay, so that's why 180 minus alpha and plus that angle will form 180, right? So if you add them up, obviously alpha is going to be equal to that angle. So here, short proof for you guys. That's pretty easy. So it should form 180. So that's why it's only possible when that angle here is equal to negative that angle, which is alpha. So in that case, you'll have 180. If it's not the case, it's not cyclic then, all right? So let's go to the problems where you need to define different unknown variables. In this case, everywhere in those three problems, you need to define variable x. Okay, let's do it quick. So what we're going to do in the problem 1, we're just simply going to use rule for opposite interior angles. So angle x and angle 82 should form 180 degrees, from where x is simply 180 minus 82. So you'll get 98 degrees. Okay. So next one, problem 2, 3x and x will form 180. So you set up an equation with repeating variable x, but the same logic, the same approach. So 4x is 180, from where you can figure out x. So angle x is 180, quarter of that. So half is 90, and one more half is going to be 45 degrees in this case. Okay, so let's go to the problem 3. So in problem 3, you need to get angle x, known that those two sides are equal. So you have that part, and there you have two equal sides. However, this is so you don't have any triangle, so that's why ideally you need to drop extra line in order to have this triangle. Okay, so let it be. We put the line from here to here. Okay, let's do it more precisely. So that's the bottom or the base of the triangle. And let's consider the triangle. So what do you know? You know that angle x is going to be also here. Okay, so maybe more precisely right there. So this angle x, yellow angle x. Okay. However, you know that within isosceles triangle, because two sides are equal, angles at the base here are going to be the same. So you can easily figure out the angle, right? Let's do that. 120 and 180, so by 30 degrees. 30 degrees here, and let's say 30 degrees over there. So we've got that this angle is 30 degrees. However, we know that this basically, so this is the angle which is that, so sorry, this segment, this chord goes through the center O, so that's why it's diameter. Because this is the diameter, we're gonna use the property for the angle, inscribed angle, which is based on diameter. So it's gonna be 90 degrees. So we can say that the small, I set up just another color, let's take that one. So this small angle is actually 90 degrees. So this is by the property of the inscribed angle, which is supported by diameter. So if we have 90 degrees and 30 degrees in total, obviously that will form angle x. So we can write that angle x is going to be simply 30 plus 90 degrees. And in total, we can figure out angle x. So it's simply 120 degrees. So this is just accidentally, because that's not normally the case, that two angles are the same. So maybe if you're given different, let's say not 120, but maybe 100 or 110, you'll get another figure for x. So don't believe that in this case you'll get 120 degrees over there. So as we actually got what? We actually got the same angles on the lateral sides of quadrilateral, so it seems to be actually the trapezium. So with parallel diameter parallel to that side. However, this was drawn not to scale, so don't believe and actually just use numerical calculations so that to prove it in mathematical way or algebraic way. All right, let's get next one. So we have another problem. So you need to find unknowns x and y. In this case, you have two unknowns x and y. In the first problem 4, we don't have anything like except for x. So let's get started. So we have again triangle, and x here is going to be the same as x here because that triangle is isosceles. So we have 110 degrees. So that means in quadrilateral, which is cyclic, so this angle is going to be also, I just use another color. So this angle is going to be also 110. So, okay, so this angle is 110. So that's why for the rest part, it is, which amount? So 70 degrees for 2x. So that's why we can form small equation 2x is 70 because the sum of all three angles, so in this case each angle x is 35 degrees. Okay, so that how it works, and this is the answer for problem 4. Let's go to problem 5. In this case we have two variables, so that's why we need to find them consequently. Alright, so first of all we see that angle 120 degrees is the central with the center coinciding with the center of the circle. So that vertex of the angle coincides with the center of the circle. So angle x is going to be inscribed supporting by the same arc, so right there, as this central angle. So it's measured basically 120 over 2, which is 60 degrees. Okay, because of inscribed angle. So inscribed angle. Okay, so next one, let's go to the angle y. So we know that x and y together will form 180 degrees using again the cyclic quadrilateral property, because the big one is inscribed cyclic quadrilateral, 4 sides. That's okay. So we know angle x is 60. So from where we can figure out angle y is simply 180 minus angle x, which is 60, and we'll get 120 degrees. Okay, let's move to the problem 6. Here we have all unknowns. However, it doesn't matter. So just don't panic. You need to get and complete the set of equations. So that's the normal practice when you don't know anything. So don't panic. Just try to complete equations or a system of equations, like in this case, I think. So 2y and x, how they connected? So that's the gain inscribed angle, and using those points, we can say that, my bad, that was central angle 2y, and that is inscribed angle. So we can connect 2y and x in the following manner. So central angle 2y is always twice the inscribed angle. So from where we know that y is equal to x, and you simply need to find x. So all angles like x, here is 2x, and here is 2x, actually will form our equation. So will form the basis for our equation. So we can connect 2x and x in simple manner. 2x and x together will form 180 degrees, because this is again cyclic quadrilateral. So right there, okay, so that's why 3x is 180, from where x is simply 60 degrees. Okay, knowing that x is 60, y is also 60 degrees, and this problem is done. So x is 60 and y is also 60. Okay, here is done. Okay, And let's go to the last set of questions or problems. So we have in question 7, we need to find unknowns. So we have cyclic quadrilaterals. So x and x minus 30 will form again 180 degrees. So from where 2x is going to be 30, we transfer there. So it's going to be 210. From where x is just the half, so 105. All right, so 105 degrees, and this is the answer for 7. Okay, so well done with that. And let's go to problem 8. Here we have angle y. Here's we have 80 degrees and angle x. Okay, so let's try to do consequently. So angle x here. So let me see. Okay, we start from angle 80 degrees and it's right there. So this angle is 80 degrees. Again, using exterior angle. 1, 2, 3, 4. Okay, it's quadrilateral. That's okay. Actually, this is the single point. That's my bad drawing. Sorry for that. Actually, I can make an excuse and correct that. All right, so next one, we've got angle 80 degrees by the property, and 18x will form 180. That's the open angle. Wow. Okay, sorry. All right, so in total will form 180 degrees. So from where x is just simply 100. Okay, so we figure out that angle x is 100 degrees. So we need to find angle y. So simply angle y is a half of the inscribed, sorry, not the half, but twice more. So this angle is central. So it's twice more than inscribed angle. So we just write 2 times 80. Okay, so that's why it will form 160 degrees in total. Okay, so we found all the angles. That was medium level. So basically it's sort of like warm up before the hardest problem. So get ready for the hardest problem. I'll create that video soon and try to work on. So that was sort of preparation. Okay, thank you. Thanks for watching. Don't forget to subscribe if you're new here. Don't forget to like and share your comments. That was Daniel Dallas. Peace out.